In this video, we're going to learn about the sampling distribution for proportions. And so in general, a sampling distribution is a probability distribution of a statistic obtained from a larger number of samples drawn from a specific population. So you should already know that the population proportion is given by the Greek letter pi, which is our parameter of interest. And we typically estimate this value using our point estimate of p hat. And so for a sampling distribution, you typically collect multiple simple random samples and calculate a sample proportion from each of those samples. And you can use all of these values to describe the distribution. You can calculate a mean, standard deviation. You can plot a stem and leaf plot to help understand the shape. And you can also calculate outliers to fully describe this distribution. However, in practice, we usually only have one sample. So when you only have one sample, we theoretically describe our distribution, and we first need to check two assumptions. The first is that it needs to be a simple random sample, and the second is that it needs to follow the central limit theorem, and we can discuss that in later videos. But for now, if you know that your two assumptions are satisfied, then you can fully describe your distribution by calculating your mean and your standard deviation. For both of these values, you have to use the formulas provided. There is no calculator method for solving for these values. And so if you use your population proportion and your sample size, once you calculate a mean and a standard deviation, we can describe our distribution using the following notation. We can state that p hat is distributed normally with a mean of mu sub p and a standard deviation of sigma sub p. And once we've written this notation, this fully describes our distribution. It gives us a center, spread, and because it's normally distributed, it describes the shape and unusual features. So this is how we describe a sampling distribution for a proportion.